Math 125, this is practice test 2. This is question number 12, it's pretty big. So take note that we have a set of elements from the integers. So it can be positive, it can be negative, it can be 0. Notice no fractions, no decimals. And our operation, a smiley face b, is a plus b times a minus b. And before we just run through the tests that we're supposed to run through, let's just mess around with this, get used to this. So let's say I had 5 smiley face 3, and I wanted to figure out what that is. Notice 5 is a, b is 3, so that's the same as 5 plus 3 times 5 minus 3. 5 plus 3 is 8, 5 minus 3 is 2, that would be 16. Or if I had something like 2 smiley face negative 7, that would be 2 plus negative 7 times 2 minus negative 7. So 2 plus negative 7, what's that? Negative 5. 2 minus negative 7 is 9. Negative 5 times 9 gives me a negative 45. So that's how that operation works. So let's look through the test. The first question, A, asks, is it commutative? Does it commute? And what that means is the order important? In other words, does a smiley face b always equal b smiley face a? Now to disprove it, we just need one counterexample. To prove it, we'd have to actually go through some pretty big proof. But let's see what happens. Let's just go, well, we already did 5 smiley face 3. So 5 smiley face 3. Does that, in fact, equal 3 smiley face 5? Think about that word commute. Like commute means to move. So we actually moved where the elements were. 5 smiley face 3, again, we've already done that work at 16. But if we do this one, 3 smiley face 5, oh, I still don't know if it equals it or not. 3 is A, 5 is B. So this would be 3 plus 5 times 3 minus 5. 3 plus 5 is 8. 3 minus 5 is negative 2. Multiply those together, that's negative 16. Not equal, so no, it does not commute. Because A plus A smiley face B did not equal B smiley face A. Next question, B, is there an identity? In other words, is there an element that if you combine it with any element from there, you get that original element back? It's like multiplying by 1. It's like adding 0. So those are actually both pretty good candidates, I think, because we have addition and multiplication going on in the operations. So let's try it. Let's go 5 smiley face 1 and see if we get 5 back. 5 plus 1 times 5 minus 1. That's 6 times 4. No, we get 24. It's not 1. Let's try 0. 5 plus 0 times 5 minus 0. Looks like no, because that's 5 times 5 is 25. So what we could do is just keep trying things and see if we actually find it. And actually, this does not have an identity. And if you look at your practice test, it actually offers proof as to why it does not have an identity. C, the next question is it closed? So in other words, I can only use integers in the operation. Will I only get integers back from the operation? And I'm going to argue yes, because I'm doing addition and subtraction. So if I add an integer or subtract an integer from an integer, I'll get an integer back. And then I'm multiplying. Also, an integer times an integer is an integer. So I'm going to say yes, because a plus b is an integer. A minus b is an integer. And an integer times an integer will give me back an integer, always. So that's closed. Last thing, associative. So in other words, associative, I'm testing basically 3 elements combined, and I want to make sure that the left side equals the right side. And notice what I'm doing with the parentheses, I'm associating them. I'm associating them in different ways. So if I change the associations, but not the order, will I get the same thing? So let's just try it with like 2, 1, and 3. So 2, smiley face 1, smiley face 3. will that be the same as 2 smiley face, 1 smiley face 3? Now let's see what happens. 2 smiley face 1, so I have to do what's in the parentheses first. That's 2 plus 1 times 2 minus 1, which is 3 times 1, which is 3. And that thing's still smiley faced by 3. 3 smiley face 3. 3 plus 3 times 3 minus 3. Looks like 9 times 0 is 0. Okay. Let's do this side and see if we get 0. So it's going to be 2 smiley face. 1 smiley face 3 is 1 plus 3 times 1 minus 3. 1 plus 3 is 4. 1 minus 3 is negative 2. That's a negative 8. So now I have 2 smiley face negative 8, which is 2 plus negative 8 times 2 minus negative 8. 2 plus negative 8 is negative 6. 2 minus negative 8 is 10. That's negative 60. Those are not equal. Therefore, associative. No, not associative. We found one counterexample.